Pretty awesome. I'm feeling pretty inspired. I don't know about you guys. It's really cool to have everyone here all together. This is my first Connect, so I'm super excited. My name's Emily. I'm the leader for the Python track. So I was just going to do a quick intro for that. If you haven't heard already, Women Who Code's launching these 6 tracks. Python's one of them. womenwhocode.com/Python. Go ahead and join for more cool talks just like this. So without further ado, I'd like to give it over to Jigyasa Grover.
Hello, everyone. Hope you're not sleepy after the lunch. So how many of you use Twitter? Nothing against you if you don't, trust me. So hi, my name is Jigyasa. I work as a machine learning engineer in the ads prediction team at Twitter. So if you use Twitter and you think you see relevant ads, especially to install apps relevant to you, I'm in that team and you know people behind that. And in case anyone wants to talk about machine learning roles at Twitter, how we work, what do we want to work, etc. And of course, we have like open positions. Feel free to, contact me after the talk, etc. So let's begin. So the year of 2018 has been done and dusted with. And with each new year comes in the TIEB's programming language of the year. And there was no surprise. For example, for those of you who don't know TIEB is the importance of being earnest, and it's a software quality company based in Amsterdam, based in Netherlands, basically. So I was not at all astonished to see that Python won the celebrated title yet again after having captured the most search engine ranking points. Also, earlier this year, 90,000 developers took the 20-minute survey conducted by Stack Overflow. And the results again showed that Python was the fastest growing major programming language and has risen the ranks of programming languages, edging out Java, Rust, etc. And ever since I've gained consciousness in this tech sphere, I've observed the admiration for Python soaring high. And the sources reveal that it has consistently been included in the top 10 programming languages since the year 2003. As the recent article by TIEB says, it's the most frequently first taught language at university nowadays, all across the world. It's number 1 in statistical domain, number 1 in AI programming, of course, number 1 in scripting, number 1 in writing system tests. Besides this, Python also leads in, web programming, scientific computing, etc. In summary, Python is everywhere. Of course, there are several reasons for the rapid rise, bloom, and dominance of Python, be it readable and maintainable code, extensive support for third libraries, integrations, modular, dynamic, portable, etc. And of course, community support. But what stands out is the flexible programming it provides. Only very few programming languages can match Python's ability to, conform to your own programming style. You don't have a particular style that you need to follow. And by programming style, I mean programming paradigms. So when you work with Python, you are the snake charmer. You can code it in imperative programming way, functional, procedural, object-oriented, anything. So before we see which programming paradigm fits which use case the best, that's what we are actually talking about today, let's do a quick revision. So revision starting with the basic, imperative programming. What is imperative programming? It's just a series of commands you write. You want to make tea, what do? You take a cup, pour in boiling water, pour in some tea leaves, etc. You just write how you write in a series of language. And at each step of your program, you have a state. You have a state of the tea. Is it just water? Is it just like the leaves have started to soak in, etc., etc. And that allows it to write in a very simple and an elegant manner. But the only thing is, it works very sequentially. Therefore, it has very comparatively slower execution on complex data structures. So, talk is cheap. Show me the code. Let's just see. So let's take a very simple example. You have a list of, say, characters, P-Y-T-H-O-N, and you need to combine them, concatenate them to make a string. So how do you start? You take an empty string, then you first put P, then you put Y, then you put T, etc., till you reach Python. So notice how we have written in each step. If you expand the for loop, basically what you're doing at each step, you are concatenating each character, and that leads to having a state of the program. So each time the state of the program is the sample string. So this is just like simple imperative coding. Let's move on to the next, functional programming, which is more of like mathematical because it's based on lambda calculus. And each thing you don't tell how to solve, you just tell what to solve in a more of like mathematical functional format. So each computation is like evaluation of a mathematical function. It's stateless. So we'll see in the example how it is stateless, but you have to see that the data structures it uses are immutable. That means once you've changed them, you cannot change them. You cannot go back to the previous state, basically. And it's very, very useful for parallel programming, recursion, etc. Let's see the code. So the same code, same example, how you see it's just been done in one single line. You just use func tools, which are the functional programming tools for Python. We can go more deep into it later. And how you've just done in one simple sentence, one simple command, you've achieved the same thing you were doing in a for loop. And the thing to mention here is there you were able to see at each step the different sample strings you were getting. Here you cannot. You get only the final result, which is the sample string Python. Let's go deep into it. So basically, these were the three main things in this program, basically. So what are func tools? Func tools are nothing, just higher order functions, which take in a function and return a function. So basically, it encourages us to write reusable code. You can take in something but return a function which further can be manipulated, and you don't have to write the first step again and again. What is functools.reduce? .reduce is nothing but you take a big list and just compress it into one single thing. So you basically take in a function and you pass in a string or you pass in a list and compress it into one. Let's see an example. You have list 1, 2, 3, 4, 5. You apply reduce. You give it the function x plus y, basically, and it calculates 1 plus 2, and then again plus 3, then again plus 4, and then again plus 5. So basically, you ended up reducing it into one simple thing. Now, you might be wondering, what is lambda here? Lambda is basically an anonymous function. It's a simple function, x plus y, but it wasn't given any name. If you know in Python, you generally give def, define a function, say foo, and then you give an expression. But here, we had the same thing, but instead, we didn't have any name. And the power of lambda is best shown when you use it for a shorter duration, basically using the function within another function. And you know you won't be using that ever again. So why give it a name? Why you waste space? Why waste energy? So this is functional programming. It's very it seems very complicated because it's tough to write in a mathematical format. But when written, when you can master this art, it helps you write so many complex things in an easier manner and in a shorter manner that you can write it for parallel processing. So this is an example of lambda function, how sample function basically returns another function. So not going deep into it, this is just for an example. We can go next to procedural programming. So procedural programming is just a subtype of imperative programming. If we go back a little while, imperative programming was nothing but just a sequence of commands. Here, the sequence of commands is still there, but the commands are not like commands themselves, they are procedure calls. So you might be having different modules in your project structure somewhere. And the main task that you have to perform, what do you do basically? You call those functions or modules you had created somewhere else. So it's a very old form of development, maybe one of the first forms of programming after imperative. And it favors lots of iteration, sequencing, selection. Just like imperative programming, it becomes very slow when you have complex and bigger distributed systems, and therefore leads to throttling. And it's a bottleneck for resource utilization. So it fancies modularization, of course, because it has modules and step-by-step iterations in tasks as functions. Again, example, best thing to understand how it works. Just imagine this stringify component was located in a different directory in your project. So when you wanted to, make a string out of characters list, you would have simply called stringify sample characters. So this is how it works. You just, to basically do what you want to do, you call those modules on the list. So containers, modules, these are all terms which are used interchangeably in like specification to procedural programming. I'm not talking about containers. So basically, combination of modules is program creation. Functions can have no relationship with each other. They exist independently. But this leads to lots of code duplication, because if you have like a larger team and in the same project, people might be writing different modules with different names, with different kinds of implementation. But what they're actually doing is the same thing. Happens to me every day. I've just joined the team like 2-3 months ago, and I ended up writing a training module, and I realized later that someone on my team had already written it, but with a different name and different variable names. It costed me a lot of time, but if I would have they would have not followed procedural programming in that particular file or that particular aspect operator, we could have like saved a lot of time and effort. So it provides a simple interface, though. You need not worry what goes inside. You just need to know what are the inputs, what kind of the format of the output is gonna come, and what it performs. No requirement of going into details, etc. for procedural programming. So everyone's following me. Am I like too fast or something? Great. So next comes object-oriented programming, which is the fad, which is generally taught in university, the first thing these days, instead of starting from simple imperative and functional programming. So Python cannot fully support object-oriented programming. Everyone should note that, because it cannot do data hiding. Anything, any variable, any method written in a Python class is visible to anyone and everyone, because Python does not have that private keyword. Anyone who comes from C++ or Java background might notice like we used to have public, protected, private, but Python does not. So a hack that Python developers do, what we do is we append like 2 underscores in front of a variable name or a module name, just to show that this is something private and should not be like, used in any other way, any other method or something. This is something that we should hide from like the public interface. So object, everyone knows it's an entity with data, with variable names and methods, and only those methods inside that class are allowed to change those variables. Object-oriented programming is complex. It's tricky. I still can't figure it out, especially writing algorithms in object-oriented as a big hassle. If you see the code, the same thing when written in object-oriented paradigm becomes so much bloated. First of all, for just doing one simple thing, you have to define a class. Then you used to have a variable, init method, and then stringify method, etc. And then you create an object. Then you apply the method on it. So sometimes, though object-oriented programming might be useful in many cases, but here it clearly is not. Why should we waste our energy writing this much just to perform one single task? So as we saw different examples, what do you think worked the best for our example? Which kind of programming paradigm would you use to perform this kind of example? Functional or imperative, if you're not comfortable writing those lambda functions. And this is what we are going to talk about today. Are we comparing these different programming paradigms? The answer is completely no, because different use cases might require different kinds of programming paradigms. And software today is nothing but knowledge representation. And to know like what kind of programming paradigm should you use, you should know that how can my problem be... Okay. Yes, sorry. So how can my problem be best represented? Once you know the answer of this question, it becomes very easy for you to choose the best programming paradigm for your particular use case. So just to give like very high level pointers to this question, let's start. So if you think your program is nothing but just a series of simple manipulations, like you have a dictionary, you have a list, and you're just like changing different parts of it at each different step. use imperative programming. Why waste energy on even coming out with a mathematical formula? Next, if you think you are doing some sort of like mathematical things, you're doing like reducing, you're doing mapping of like one list to another list, you are doing filtration, you're just like taking out some random values from the list based on certain conditions, follow functional programming. And if you think your program is more of like objects, you have different objects like cars, buses, etc., and their like data, their attributes interact with each other in a certain way, go for object-oriented programming. And not only this, you'll have to check for like dynamic, static needs, etc., etc. So before jumping into like what kind of programming paradigm you want, first you need to figure out these kind of questions and then make the roadmap accordingly. So now we'll be talking about buzzwords, going into like real life examples of what is used where. So when you think of buzzwords in today's world of tech, what's the first thing that comes to your mind? Exactly. We'll be talking about machine learning. This is the buzzword, the hot topic these days. So machine learning, it's a very healthy mix. You cannot figure out if to use imperative, functional, object-oriented, procedural. Forget procedural, not at all. So you start with functional programming. Then you have imperative programming with a tinge of immutability. So basically, it's a healthy mix. You cannot just rely on one simple paradigm. Let's see how. So in machine learning, the first thing is pre-processing the data, doing the feature extraction. So what do? You basically filter out stuff you don't need. You map stuff to different values. For example, I have like green eyes or blue eyes of like something, and then you don't use this green and blue. You map them to like +1 or -1 for machine learning, because that's how maths behind machine learning algorithms work. So that's why you do functional, because you're mapping stuff, you're filtering stuff, you're reducing stuff. But when it comes to training of the machine learning models, you cannot do it in a functional programming way. Of course you can, but the best thing would be imperative. Why? Because at each stage, you want to, graph out the loss function. You want to graph out the accuracy. You want the state of the training model at each training step. So, and it's best done in imperative way. It's quicker than functional if you do like timing behind it. And of course, it avoids creating copies of everything. Why? Because I have the same data structure, which I'm modifying again and again. So I have weights. I just like modify again and again, like y is equals to mx plus b. Basically, that's what we do in linear regression. So we don't need different values of m. We don't need different values of b. We just need to modify them at each step so that we get the least loss as possible. Am I clear to everyone? Great. And next comes deep learning. Deep learning is nothing, just a very fancy term for machine learning. It's a subtype of machine learning. So when you see deep learning, you see big this network, and beneath this network, at each small step, you have this complex mathematical function. So whenever math comes in around, think functional, think the functional way. So how do you do functional way? And why do we do functional way? The first thing is because deep learning models are compositional. They are all mathematical in nature. So the best thing to do would be in a composition, in a function. Like they are basically functions combined with each other. The weights in deep learning are immutable and they are stateless. They don't depend on others unless it's an input to themselves. So as long as inputs of each component is computed, you can update any weight at any time. And then, of course, it gives concurrency and parallelism at no cost. Easy to work, recursion, parallelism, etc. at functional programming. So if you're doing deep learning, don't make classes, etc. Try writing functional. You always have like the mathematical formula when you do deep learning. You just have to like code it up in Python, and it's super easy these days. Next. Also, in machine learning, there's a new programming paradigm which combines functional programming with information theory. And this information theories help to prevent overfitting. Not going deep into this because many people might not be from machine learning background. And there's a paper on it if anyone wants to, go deep into it. It's just a programming paradigm for machine learning with a case study of Bayesian networks. It's a good thing. It talks about how, stuff like information theory can be helped in deep learning or machine learning to prevent overfitting, other than regularization, etc. Then comes data manipulation. Today we have like lots and lots of data, and we need to, as I said, filter it, reduce it, etc. So other than the option one is, of course, functional programming, because everything is immutable. Algorithms can be written in a very short form and you can understand them better. But the downside is knowing and understanding. The first time I started with data science, I couldn't just figure out how to write lambda functions. I was so lost because I used to, do pair programming with a friend of mine to do homework assignments. And I used to see that she used to write everything in just like one line in Jupyter Notebook. And mine used to be like, 5-6 lines until I reached the same point. And I would like to thank her because of that. I used to, learn how she taught me how to, compress 2 lines at a time, then 2 lines again at a time until you reach a functional programming way. And of course, this is an art. I repeat, functional programming is an art. Not everyone can write dot reduce, dot map with lambda functions inside it. And some people even write, nested lambda functions. I don't even know how can they do it. So of course it's tricky. So many people resort to option 2, which is object-oriented programming. Because you're able to write recursion and iteration, you can just make objects for different data structures, and you have methods to, manipulate them, etc. But the downside is algorithms are not in a readable way. Just take a very basic example of a graph theory when you do, say, like path-finding algorithms in graphs. If you write in an imperative and a functional way, it will be very easy. But if you write in an object-oriented way, a very simple algorithm can become too complex because you don't know they're like manipulating data using different methods. Just try opening a book, which I remember the Corman book does it in 2 different ways. They have a chapter, I can't remember, but yeah, if you just look it up, writing algorithms in object-oriented programming can be very tough. It's just like because it's not sequential, your brain can get a little bit drowsy in processing it. But the best thing is both paradigms have automatic garbage collection system and access to database very easily. The only thing is you have to choose option based on your knowledge. If you can write functional better or you can write object better. Next, the next buzzword is IoT. So I'm just talking about buzzwords. And most of them end up being functional programming. And you know all why, because it's just easier to, all these are nothing but just maths. And maths is best represented functional way. And then, of course, there are 2 different subtypes. There are data flow programming and event-driven programming. They are derived from functional programming, and they just consider like different pieces of data. For example, if you have Alexa at home, they have like event-driven because assuming it's not on every time and it's not listening to you every time. It's assumed to be event-driven because when you just call out her or his or its name, it will get active. So these are event-driven programming. Again, each operator in events triggers a functional program which written. But one thing to be noted is we talked a lot about functional programming, etc. I work in the commercial like Twitter, where we do ads prediction. And trust me, not everything's functional because not everyone can write that clearly. It's mostly used in academia, in papers, etc. When researchers directly convert the mathematical formula into code. So it's morely used in research papers, academia, etc. Commercial software development is a mix of everything. Sometimes you would wonder what kind of programming paradigm have I come up with, because we are using like a mix of everything. So what is the major takeaway from this talk? The thing is, you just have to mix and match. You have to write, there is not one particular way of doing things. We just saw that machine learning itself cannot be a program because it consists of parts like feature extraction, pre-processing, training, evaluation, etc. And each step required a different programming paradigm. So the best is to do trial and error. And of course, when you think you've come up with a good thing, make sure that you jot it down. You share the document with the community, with your team, etc. Because you never know, the problem you solve today might help solve so many other problems tomorrow. Thank you so much. Any questions?
So I wasn't really clear on the difference between imperative and procedural. So what you were calling imperative seemed procedural, and then you introduced procedural, and as maybe the differences were too subtle for me to recognize. So could you?
Yeah, as I said, procedural, like they are kind of like subtypes of each other. So in imperative, you just go like each command is written in a sequence, where in procedural, the command is a call to a procedure. So it's not a command in itself. It's just a call to a procedure which might be written in some other paradigm.
It's more of a curiosity thing. I often come across like functional programming libraries in which everyone is playing code golf, and I wonder how much of that is like useful and sort of inherent to that style and like it should be that way. How much of it is just people showing off? Like, is there a reason it can't be more readable?
Off. Yeah, trust me.
Follow-up question, has anyone written a utility to unpack this and expand it?
I have no idea. Sorry about that. Yeah, you can open source a project maybe.
Hello, how are you?
Pretty good. How about you?
I'm fine. So I want to join the machine learning, and I wanted to ask you something because you're in there.
Mm-hmm.
I've been diving more into their models. I've been trying to understand them more. So since you've worked in the sector, so what kind of models are you using? Because I'm more interested in understanding the models more.
Yeah, sure. So at Twitter, we use we have at basic we use TensorFlow, but we have so many custom libraries, of course, suitable to our needs, and we use deep neural networks.
Oh, okay.
Yeah.
Okay.
And then every day is a training day. You just keep on tuning the parameters till you get the best.
How much in your work that you feel a good coding convention is greatly helpful in terms of improving the readability and maintainability?
So I'll talk about a very relevant example, which is going on in my team right now. So because we are nearing our launch, so what do? Everyone's just like, putting random stuff in, writing imperative code, just, line by line. And then because our priority is to, launch the product, so we need to just improve the accuracy, basically. But side by side, we try to make it modular as well. But it all depends on priority. Many a time, things start with like pure imperative. We just like write line by line. But then there comes a stage when it becomes like too much bloated. And that's where libraries come in. That's where you write utilities and refactor your code. So I think that becomes very useful, especially when a new developer comes in and you have to like onboard the developer. It is easy to write a line by line code, but then there comes a stage when it's just too much to handle.
Thank you.
You're welcome.
Anybody else? All right. Oh.
Hi. This is not directly related to the different paradigms, but I'm just curious, how does Twitter know when it's algorithm weighting? Like, say you have a project, you've tuned things, you have the right weighting, to whatever, make recommendations to people or whatever it is that you're doing. How do you know when those weights have gotten stale? Like, when to update those later on in product?
So it happens in batches because every few hours, every few days, people change preferences. So we just keep it like, it's like kind of like ongoing. It's just not like a model which is just deployed and then it goes for like months.
Okay, so yeah, you have some components like on the client itself, or like when you know when they change their preferences and things like that, and the algorithm updates.
Yeah. So I said it happens in batches.
Yeah.
So after like some X amount of hours, X amount of days.
Okay, you sort of like retune or
Yeah.
you like recompute new
Yes.
coefficients or whatever. Okay, thanks.
There's a question here.
So I've never really used functional programming before. Does it affect time complexity? Like, for example, with the basic example that you gave of the string printing Python. So is the time complexity same in, for example, the one that you showed?
So in the example I showed, it was a very tiny example.
basic,
Yeah. But as I said, if you do, for example, if you have like a large data set and if you want to do mapping, for example, if it's green, map it to +1. If it's blue, map it to -1. It will be obviously better to use functional programming because you can break down data sets and do like in parallel everything.
Right.
But in imperative, you would be going to like each data point and doing the mapping. So it helps in like bigger data structures. So basically in map, what you do is like at once, everything gets mapped. In imperative, you'd be doing like taking one data point, mapping it, and then doing it. Just doing the if condition there.
Got a few minutes left. All right, well, let's give it up for Jigyasa.
Thank you.